Let's start lab 6. Use the US crime data to extract 4 columns of data: murder, robbery, larceny, burglary for California. Your task is to use multiple regression and predict the murder count based on the other 3 variables. Create appropriate regression table and answer the following question. So here in this question, we need to predict murder of California by using robbery, larceny, burglary. Okay, open US crime data. So we have got US crime data for this one. Now since we want California's data, so we go for, just click on the first cell and go for sort and filter, go for filter, then in state you deselect all and just click on California, click on OK. So that's fine. So here we need murder count, so that's why let us just go for murder count at first. For the murder count, you select this column E, Ctrl C for copy, and then paste in a new worksheet, Ctrl V. So let me write down this is a murder. So let me go for robbery. Okay, so this is robbery, Ctrl C. Next to murder, you just paste it there and write down robbery. The third one, larceny. Click on OK, and here you get larceny's count. So Ctrl C and Ctrl V. So this is larceny. And finally the fourth one is burglary. So burglary and larceny. Okay, so we have burglary count here, so Ctrl C, Ctrl V. So this is burglary. Okay, now here what we need to understand is this is Y variable. Let me write down this as Y. And first one, this robbery is X1, so let me just write down X1. Robbery X1, larceny is X2, and finally the burglary is X3. Here the Y variable would be approximated by or predicted by these 3 variables: robbery, larceny and burglary. So let us try to come up with regression table for this one. So let us go for data analysis, regression, click on OK. So input Y range is for this one, okay, the column number A. So for this one, let us go for this and up to 47th row, and go for input X range. Input X range is for this X1, X2, X. So that's it. Alright, click on labels and click on OK. So you'll be getting a new regression table. Now let us look at the questions. So what is the standard error and what would be a one sentence interpretation of this number? The standard error is simply this one, 168.56. 168.56. Okay, so 169 it would be the approximate answer. Choice A, 169. Our prediction for the number of murders would be enlarged by 169 murders. That's not the correct interpretation. Our prediction for number of murders will be accurate plus minus 169 murders. This is the correct interpretation. It is the number of murders? No. It is the number of predicted murders if other crimes are 0? No. So this one, B, is the correct choice. What is the coefficient next to burglary? And what would be a one sentence interpretation of it? Burglary 0.000166. That's the coefficient. For 1 unit change in burglary, we expect that the murder will be changed by 0.000166. So that would be the correct interpretation. So here choice A, 0.000166. For each burglary the number of murders increases by this amount. Okay, so this is the correct choice. Let us see if there is any other better answer. B, in case of 0 burglaries we expect this amount of murders. No, that's not the correct one. This one, when numbers of burglaries are 0, intercept is no, that's not the correct one. So that's the correct answer. What is the statistical interpretation of the number negative 68.27? Okay, negative 68.27 is intercept. Our model for this problem would look something just like this: y equals to c plus m1 x1 plus m2 x2 plus m3 x3, where this c is the intercept, which is this one, negative 68.27. m1 is 0.02513. x1 is the number of robberies, and m2 is the coefficient of x2, which is 0.000844. x2 is the number of larcenies, and m3 is the number of burglaries. Okay, coefficient for burglaries 0.000166, and x3 is the number of burglaries. So if x1, x2, x3 all of them are 0, then y equals to c, which is the y-intercept. In the year where California has 0 robbery, 0 larceny, and 0 burglary, then they might expect negative crime, negative murder rate of 68.27. So that would be the interpretation, but that's quite absurd. A, it tells us how accurate the prediction is. No, that's not the correct one. It is negative, so it does not offer any statistical prediction. No, we can't say that. It is the x-intercept. No, that's not the correct one. It tells us the number of murders if there are 0 robberies, larcenies, and burglaries. So that's one. Given an interval of prediction of a murder count of California, if we recorded 65,000 counts of robbery, 71,500 counts of larceny, and 21,550 counts of burglary, then which would give us the interval prediction of murder count in California? So let us go towards our model. Okay, so let me just simply copy this one, Control C, and paste it here. Now let me write down the predicted murder. This would be equals C. Coefficient is negative 68.2705 plus M1. M1 is this one, robbery, which is 0.025137 times, that's robbery, means B2, plus x2. M2 is 0.0008, 0.1230845 times larceny lies in C2 plus 0.000166 times D2. So that's it. So that is our model. C plus M1 x1, M2 x2, M3 x3. Okay. Now let me drag it down, all the way down. Okay, so that's fine. And here, so let me just delete those two. Here, according to the question, 65,000 counts of robbery. B, 65,000. Let me write down 65,000. 71,500 counts of larceny. And finally, we have 215,500. 215. Okay, counts of burglary. So that's fine. Then you can see 2205 would be the predicted murder count. Okay, now to get the interval of prediction, so we what we need to do is we need to add and subtract the standard error. So standard error is 168.56. 168.56. Okay, standard error is 168.56. Alright, so here the left endpoint would be something just like this, equals this one minus 168.56. So that's this left endpoint, and the right endpoint would be equals the predicted murder count plus the standard error. So 2037, 2374, 2037. Okay, so C is the correct choice. Okay, so that's task 1. Let's go to task 2. Please go through this yourself. Okay, open SAT data and go for all of these things, and here you are required to go through the p-values. Okay, So now you can definitely do this, and you already know where the p-value is. Okay, so now let us go for task 3, selecting good p-values. Okay, you can go through this again yourself. Task 4, use the SAT data and through multiple regressions select the 2 variables that predict college GPA. Make the best GPA the best. Make another table with these 2 variables and answer the question based on this table. Numerical answer rounded, so choose the answer that matches the best. Okay, here I have uploaded the SAT data and corrected the headers. Okay, please do so if you haven't done. Now let's go to data analysis, regression, click on OK. We should predict the college GPA. And for the other 3 variables, for X values, you go for these 3 variables: high school GPA, SAT, and letters of recommendation, quality of letter of recommendation. So that's it. Then B1 up to D101. So click on labels and click on OK. So we get this regression table. So double click this one. Okay, so all we need is R square, standard error, these coefficients, and the p-values. Okay, here click there. Okay, so now the question has clearly asked that we need to select the 2 variables that predict the college GPA the best. Okay, for this one we need to check the p-values of the given variables. So high school GPA, SAT, and letters of recommendation, those are the 3 variables that is used to predict the college GPA. So now let's check their p-values. Okay, these 3 things, these 3 numbers. Now we know that p-value, lesser the better. Okay, we always try to look for p-values which is less than 5% or 0.05. Here you can see that for high school GPA 0.001, 0.0013, that's very less than 5% or 0.05, so that's good. For SAT it's 0.0000105, that's even better. And for this one, letters of recommendation, it is 0.657, so that's 65%, which is way greater than 5%. Okay, so we would go for high school GPA and SAT only. Right? Those 2 will be the variables that we would use to predict the college GPA. So without a delay, let me just try to make predicted college GPA. Predicted college GPA, and as I told you slightly a while ago that we won't be using this letter of recommendation. Let me just mark this as, let's say, by this color, as if I am discarding it. Okay, for predicted college GPA we need the model. To find out the model, we would just go for this one. Right, I don't need letter of recommendation, so let me just copy these 3 things: intercept, high school, and SAT. Okay, Control C and paste it somewhere here. Okay, so the model would be equals, intercept is negative 0.15326 plus m1x1. m1x1 is this one, so m1 is 0.376351 times x1 is high school GPA plus m2 is 0.001227 times SAT C2. That's m2, right? So thus we get this value. Okay, now let us drag this all the way down. Okay, so that's fine. Now here it says that what is the predicted college GPA for the student with high school GPA 3.2, SAT 1100, and letters 9. Okay, we just need to select 2 variables that predict the college GPA best. Okay, and make another table with these 2 variables and answer the question based on this table. So we won't be requiring this one, so we would be just going for these 2 things and predict the college GPA from these 2. High school GPA 3.2, SAT 1100. So here 3.2, that's the high school GPA, and 1100 is the SAT. Okay, so that's 2.40 is the predicted college GPA. So let's go for that. Okay. Now, what is the standard error of this prediction? Give an interval of this interval prediction. Okay, so let's go for standard error is 0.58. 0.5894, 0.584. Okay, so that's fine. And the interval of prediction would be equals the gotten value, predicted value, minus the standard error. So that's the left endpoint. And for the right endpoint, you just go for equals the predicted value plus the error. 2.99, 1.81 up to 2.99. 1.81 up to 2.99. So this is the predicted college. This is the interval of prediction. What is the coefficient of SAT and what is it the interpretation? Coefficient of SAT. Coefficient of SAT is 0.00122. Alright, and now coefficient of SAT is this one, equals 0.0012227. That's the coefficient of SAT. Now, if the SAT score increases by 1 unit, then the predicted college GPA will increase by this number. Okay. Furthermore, in other words, you can say if SAT score increases by 100, then the predicted college GPA will increase by 0.1227. So either way. This one, no, that's not a good thing. This is not the coefficient of SAT. This is also not the coefficient of SAT. C, 0.1217. No, that's not the correct coefficient of SAT. This is the only correct coefficient of SAT. And it says for additional 100 points scored on SAT, a student's college GPA increases by 0.1227. Okay, so that's it. Alright. Now here, if a student A's high school GPA is 0.35 point lower than student B's, and on the other hand, student B's SAT score is lower than student A by 150 points, which of the two students will have higher predicted college GPA and by how much? This is student B, so that's 3.35. Then student A would be getting 3.0. Okay, so that's it. And now student B's SAT score is lower than student A's by 150 points. So that means student A will have gotten, let's suppose, 1350 SAT score. Then student B would have gotten 1200. Okay, so that's fine. Now what would be the scores? So you can see that student A has gotten 2.63 as the predicted college GPA, and for B it is 2.5799 or 2.58. So then you can clearly see that 2.58, okay, 2.63 minus 2.58 would be 0.05. That's the difference. Student A by 0.04 points. Okay, so that's it. Now let's go for task 5. Okay, task 5. Use the house price data and through multiple regression select two variables that predict the house selling price the best. Make another table with these two variables and answer the questions. Okay, so for this one, let us go for data. We have already uploaded the house price data file, and data analysis, go for regression, click on OK. So our Y value would be house price. So selling price in 100,000. Okay, so that's the house price, and everything else is, so that's the Y range that is to be predicted, and input X range would be all of these four things. Okay, A is bathrooms, number of bathroom, number of room, number of bedrooms, and number of fireplaces. So from here up to here, that's the X range. Okay, A1 up to E29. That's fine. So click on OK. Don't forget to tick the labels. Regression table. This is our regression table, and this is the p-value. Okay, so now here also we would only choose the p-values which are less than 5%, or in worst case we will choose the lower p-values. That's all. Okay, so this one is intercept, so we would just ignore for now, and let's just try to focus on this one. So here for the p-values, let us talk about these 5 p-values. Okay, 0.032, that's less than 5%, that's good. 0.0007, that's even better, it's very less, it's quite less. Okay, 0.09, that's 9%, 50%, and 33%. No, we won't go for that. So for us, we will be taking age and number of bathrooms to be the predictors of selling price. So now let us go for selling price of the house and age and bathroom to be others. Control C and make a new worksheet. So that's fine. Age and number of bathrooms will predict selling price in $100,000. We have created a new model now. Okay, now let's go for the regression data for this one. So go for data analysis, regression, click on OK. So delete this and delete this also. Okay, input Y range is selling price. That's fine. And then our predicted the variables prediction is area, age and number of bathrooms. So that's one. Click on OK. So that's it. So we got our regression table, right? And now here p-value is this one. Question number 9 says identify the negative coefficient. What is its value and what is the interpretation of this number? Is this one. Age has negative coefficient. Okay, negative 0.03. So negative 0.036. The negative numbers and serves no statistical interpretation in this case. No, that's not the correct one. Negative 0.037. This is how much the selling price of the house will decrease in 100,000s as the house becomes older by a year. Okay, so that's the correct interpretation. Since negative number means the price of the house decreases, and it decreases due to the aging process of the house. Which of the two variables has better p-value? And what is this p-value? Okay. Here you can see that the p-values are 0.06 and this is 1.08227 e to the power negative 09. So that means this value would be 0.12345678108 1082277. So that would be the correct form of how we would write this thing, and you can see that what is this number, right? So both are very small numbers. However, number of bathrooms, that's the best p-value that we have among those two. So age has the best p-value. No, that's not the one. The higher the p-value, the better. No, that's not true. Number of bathroom has the best p-value. That's good. All p-values are poor. No. C is the correct answer. Using this second table, predict the selling price of a house that is 10 years old, 2 bathrooms and 3 rooms. Okay, so for this one, we have just found out 2 variables that predict the house selling price. So we would just go for 10 years old and 2 bathrooms, not the 3 rooms. Okay, we don't want to go for that since that's not in our model. So go for this one. So age is 10 and bathroom 3. Let me just double check it. 2 bathroom. Okay, that's 2. Okay, predicted. Predicted selling price in $100,000. Let us come up with this coefficient table and let us copy it and let me paste it somewhere here. Control B. So our model would be equals, the coefficient is, the intercept is 0.98 at 727 plus M1 is negative, so that becomes negative 0.03694 times age is A2 and plus bathroom, number of bathroom is 5.97 4556 times number of bathroom is this one 5.41. Okay, So that's it, and let me drag it down. Right, so that's fine. Now let us just make this familiar to our eyes. So let us just multiply the predicted SP selling price in 100,000. So that means equals the predicted price in terms of decimal times 100,000. So our price would be 12,125,6844. So this is the one, right? So 12.57 hundred thousands. Okay. Now, based on the table, would you characterize the regression fit, the prediction as poor, good, very good, or excellent? For this one, we would simply go for the regression table and look for the R squared. So that's 0.80, which is a very good prediction. Okay. Let's go for task 6. Use the CO2 data and through multiple regression select the 2 variables that predict CO2 level with best p-value. Make another table with these p-values and answer the questions. Okay, here I have uploaded the CO2 data, and now I want to predict this values by using our traffic and wind. So for that one, let me copy this thing hour and paste it somewhere here. Okay, so that everything will look nicer. Okay, so this will resolve our technical difficulty. If we have this hour before CO2, then it might give us some technical difficulty. Okay, so go to data analysis and regression, click on OK. So let me delete this and delete this. Our Y value is CO2, select this, and X value is, select these things. Okay, so click on OK, and now we have gotten our regression table. Let me go for these things. Okay, so here you can see that traffic, wind, and hour. So these three, you can see that traffic, this variable has a very less p-value, which is 3.1487 e to the power negative 11, and wind has 0.0069, so that's a very small p-value. 0.74, that's not a good p-value, it's 74%. No, so traffic and wind would be our predictor. So let us go for these three things. Okay, alright, here it says what are the 2 selected variables. 2 selected variables are traffic and wind, right? So wind and traffic. Okay, that's fine. And which of the variables has better p-values, and what is this p-value? Okay, so here we need to make another table. So let's go for this one. Let us go for these 3 things and Control C, and let us paste it somewhere here and go to data analysis, regression, click on OK. So A1 up to A25, that's good, and B1 up to C25. Okay, so let us change this as C25. Okay, click on OK. So thus we used those 2 prediction variables to predict the CO2 levels. Now here you can see that traffic and wind, they have very less p-values, and the second question says that which of the variable has better p-value. Of course the better p-value is of this one, traffic, which is 6.8491 e to the power negative 12. So this is the better p-value, lesser the better. So that would be this one, traffic. Alright, based on this table, how would you characterize the regression fit? For that one, we would just go for R square. So that would be 9.4. That's quite excellent. Alright, what is the another name for coefficient 1.27? 1.27. So that's y-intercept. Y-intercept, and what is its interpretation based on the data? So the x-intercept, no, that's not the correct one. The slope of an average summary, no, that's not a slope. Y-intercept, these 2 might be correct. So let's see. Y-intercept, it is how much CO2 concentration will increase when both average weekdays traffic density and the perpendicular wind stream components are 0. That's fine. That looks very convincing. The y-intercept, it is average summer weekday CO2 concentration on average weekday traffic density, and so it is not talking about average. Okay, so it is not talking about average summer weekday, so that's why we go for C. Alright, so that's it. Let's go for task 7. Task 7 is about this data. There are two tables. Here is this regression table and here is another summary table of dealer cost, this variable dealer cost. Okay, and we can clearly see that this dealer cost is predicted by x variable 1, x variable 2, x variable 3 and 4. R square is 0.7367, standard error is 7532, and so on. And p values, you can see that variable 1, variable 2 has very small p value, and 1 and 2 they have the smallest p. Okay, sorry, variable 2 and variable 3 has the smallest p values. They will be the predictors for the dealer cost variable. Okay, so here the above two tables related to variable dealer cost. First is a regression table with 4 variables predicting the dealer cost, while the second table contains the summary statistics related to dealer cost data. Answer the following questions. Choose the most appropriate answer. If variable 1 increases by 10 units according to the table, what would happen to the prediction? Variable 1 increases by 10 units, then this quantity, this coefficient negative 2838.32 should be multiplied by 10. Alright, so that means it will decrease by this one. This dealer cost will decrease by 283832. Okay, so that's it. Since negative means decreasing, right? Okay, and for others also you can see that the dealer cost will be about this one. No, that's not the correct one. Since standard error is this one, no, that has nothing to do with the standard error, since this is the coefficient. Okay, and no conclusion because R square is too large. Okay, so no, that's not the correct one. If all 4 variables increase by 0 units, so if all of these are 0, then intercept would be 208.93. Okay, so dealer cost would be 208.93. It is not about increasing or decreasing. Okay, so this is quite tricky. So dealer cost would be 208.93 units. Now, why I am saying this is 208.93, not increasing by 208.93, is that this intercept in real business terms, it means fixed cost. Just like, let's suppose you have a business, then if you give salary to your employees, those are variable costs. Okay, and the costs just like your rent, electricity, and office stationery item, cost of office stationery items, those are fixed cost, and that is represented by intercept, and those are always fixed, it doesn't change. Okay, so that's why I would just say it would be 208.93 unit, not would increase by this one. This is not the correct ones. Okay, what was the smallest observed dealer cost? Smallest observed dealer cost would be in this table, that's minimum 9875, none of the above. What was the smallest observed dealer cost? So smallest observed dealer cost is minimum 9875. So here 23792, this one 7532, no, none of the above, since we know that 9875 is the minimum cost and so on. Which number should be used in order to answer the question, is variable 2 related to dealer cost? Is variable 2 related to dealer cost? That means can we use variable 2 to predict dealer cost? So that amounts to p value. So p value of variable 2 is 0.000615. None of this. Okay, since that's p value which answers this question. Okay, once a prediction is made, we often provide a range where we believe the true value will lie. What is the number used to construct this range? That number is known as standard error, which is 7532. Which number describes the average of the variable dealer cost? The best. Average means mean, right? So that's 27385. Okay, so that's fine.